Hello everyone, myself Jianusha, working as lecturer in physics at SS Government Polytechnic, Zahirabad, and I'm working in general section under the Department of Technical Education, Telangana, and I'm teaching for first year, second sem students. The subject is applied physics with the subject code 18 common 203F, and the topic what we were discussing is fifth chapter from our syllabus, that is electricity and measuring instruments. And in today's session we are going to learn about meter bridge with the help of a small PowerPoint presentation here. The main objective of our class is, on completion of this period, you would be able to understand what is meter bridge and its importance, and how we can measure an unknown resistance with the help of meter bridge, and also we can measure specific resistance. Now let us recall what we learned in the previous session, that is recap for our class. In the last period we studied about Wheatstone bridge. So there we have seen the balancing condition of Wheatstone bridge. Now here you can see meter bridge, which is simply application of Wheatstone bridge. Now here you can see the same circuit which is designed in practical way and theoretical way. On left hand side you can see theoretical circuit. Let me explain what is practical circuit of meter bridge. Now you can see L-shaped metal bars which are placed such a way that it is forming two gaps. Now at both the gaps we are connecting, at one gap we are connecting one resistor, and at another gap we are connecting resistance box. Now you can see, as it is like Wheatstone bridge, where we are having A, B, C, D. AC is connected. Okay, here AB is MF and CD is connected with galvanometer. Similarly, here in practical circuit, AB is connected with the battery, and C and D points are connected with galvanometer. Now, why it is called as meter bridge? Because here we are using a wire of length 1 meter, which is placed near to a 1 meter scale, which is simply 100 centimeter. Now at galvanometer we are using a device jockey. With the help of this jockey we can see the current which is passing through this 1 meter wire. Now as we all know that at balancing condition of Wheatstone bridge there is no current passing through galvanometer. So we need to find this balancing point at which there is no current passing through the galvanometer. So we move jockey on this wire which is placed between A and B. As we are moving this jockey on the wire, at some point the galvanometer shows no deflection. That means the bridge is balanced. So we consider this point as D. From A to D we call it as balancing length. You can see in the diagram we have taken two lengths, L1 and L2. So let us move on to the diagram here. The meter bridge consists of a resistance wire AB, which is of uniform cross section of length 1 meter. The wire AB is connected between L shape of copper or brass metal strips. These strips are M and N, which are fixed on wooden board. Now, when we place these metal strips, they're forming two gaps with the help of another metal strip C. Now, a meter scale is fixed parallel to the meter bridge wire. Now, when a battery A and a plug key are connected in series between the ends of bridge wire, between C and jockey D, a high resistance and galvanometer connected in series. Now, the unknown resistance X in the front gap, a resistance RB is connected in the second gap. Okay, it is first gap. Now you can see in the picture that gap is we are indicating it with DF. So at this gap we are placing an unknown resistance X, and at second gap, that is at HK, we connected one resistance box. Now the jockey J is pressed at the two ends of wire on the bridge. If the deflections are in the opposite directions, then connections are correctly made. Now if deflections are not opposite, adjust resistance in the resistance box such that deflections are opposite when jockey J is pressed at the two ends of wire. Now the jockey J is pressed along the length of wire AB. At one position the deflection becomes 0. So this is what I just explained. Now this point is called as balancing point or null point. Now then high resistance is disconnected and exact balancing point D is located. Now the length AD, we consider it as L1, and the other length DB, that is L2, which is simply 100 minus L1. Now resistance R in the resistance box is noted. Now resistance box is nothing but the resistors which are connected in series, a number of resistors which are connected in series. That means we know the resistance which is present in resistance box. So using Wheatstone bridge condition, that is P by Q equals to R by S. In place of P, we are having unknown resistance X. In place of Q, we are having resistance box resistance. We are considering it as R. And the other two resistances, we are considering length of the wire, because as we know that resistance is directly proportional to length. In place of resistance, we are measuring length of the wire. So by using this formula, we can measure what is unknown resistance. So this experiment is repeated for different values of R in resistance box so that we can measure X value, and average value of X is the resistance of the conductor. So this is the tabular form, we can use it. So serial number, resistance in left side gap, balancing length of the wire, and the formula for X is equals to R into L1 by L2. Now how we can measure specific resistance? The length of the wire is measured, and we are calculating the value of resistance, and we can find the radius of the wire. By using screw gauge, we can measure the radius. So the specific resistance is calculated using the formula pi r square into X by L. So while doing this experiment, we need to take some precautions. This jockey should not be dragged on the wire. Contact should be made point to point. Very important precaution. High resistance should be disconnected near the balancing point. Current should be passed in the circuit only while taking reading. So when we are not taking reading, we can switch off the battery, or else we can open the key which is connected at the battery. So what we discussed in this session, we discussed about how we can construct a meter bridge and what is the experimental procedure of meter bridge to find resistance and specific resistance of the given wire. So the principle of meter bridge is law of conservation of energy, or simply it is meter bridge or Wheatstone bridge, or none of the above. It is meter bridge. The resistance in the left gap of a meter bridge is heated. The balancing point shift towards right gap, left gap, no change and fluctuations. It shifts towards right gap. Resistance of wire depends on length, area of cross section equal to wire and indirectly proportional to length. It is directly proportional to length. Deflections in the galvanometer are when meter bridge connections are correct. Null deflection, one direction, opposite directions, none of the above. When all connections are correct, deflections in the galvanometer are in opposite direction. The balancing point of meter bridge is 40 centimeter. The ratio of the resistance in the left gap to right gap is 1 is to 1, 2 is to 3, 3 is to 2, or 40 is to 50. So you can see the balancing point is 40, the other length is 100 minus 40, that is 60. So 40 by 60, so we get the ratio as 2 is to 3. Now, formula for calculating specific resistance S of a wire of length L, radius R and resistance X is pi r square L by A, pi r square A by L, pi r square X by L. It is pi r square X by L. So here are frequently asked questions from this session or from this topic. Describe the construction of meter bridge and describe an experiment to find specific resistance of a given wire. So this is about meter bridge. I hope you understood or you learned about meter bridge, which is application of Wheatstone bridge. So with this I am concluding. Thank you so much. So what is the use of meter bridge, or what is the use of constructing a bridge like a Wheatstone bridge, practically known as meter bridge? By using that we can find resistance of an unknown, okay, resistant or unknown resistance of a wire, and also we can find the specific resistance or resistivity of that wire by using meter bridge when it is designed in a way like Wheatstone bridge. So that is practical application of Wheatstone bridge. Remember this formula, very important one. Formula for calculating specific resistance is pi r square X by L, where R is radius of the wire, X is its resistance and L is its length. So while doing this practical, or while doing this experiment, we need to take some precautions that only when we are doing experiment we need to switch on the battery, and otherwise we can switch it off. With this I'm closing. Once again, thank you so much.